Okay, we let us start our the functions. We can prove that how the function can be written as different way. F of x, suppose f of is a continuous function in a closed interval, and up to its nth order derivative exists. The statement of this Taylor's theorem and n plus 1 order derivative is continuous in a closed interval. For example, I can say that if suppose n is equal to 3, how can we write this? F of b can be the function value at b can be written in different way. It can be written like this: f of b is equal to f of a plus f dash of a into b minus a plus f double dash of 2 divided by 2 factorial b minus a whole square plus f triple dash of a into b minus a whole cube divided by 3 factorial into fourth order derivative of c divided by 4 factorial and b minus a raised to 4 at c sum belongs to c. You can stop at this fourth order derivative. N is equal, you can stop at third order derivative. This expression is p of 3, you can write it r of 3. Okay, now how can we, based on the auxiliary function, you can write down the same function whatever the value of f of b. See, if you take n is equal to 3, you can write like this. Or I'm going to see here, wait a minute. Suppose if you take n is equal to 4, we can same function, whatever the same function, only thing by we can also be written like this. Means this can be written as P4 plus R4. Initially we can write the same function. How we can same, I will need to prove here. Okay, coming to the statement again. See, what is the, constructing the auxiliary function? We are going to construct auxiliary function like this, no problem, because these are f of x is value is exist, f of a value exist, and these f dash of a are continuous because of up to fourth order derivative taken up to, I can say that uh, what you can say, n is equal to third order derivative I'm going to take in here. Therefore we can say that these things exist. No doubt we can construct the functions, auxiliary functions like this. And after constructing, if you work out the phi of a, that is equal to 0. Even though if you work out phi dash of a, that is if you differentiate this and substituting a is equal to, you can get 0 again. If you phi double dash of a is equal to 0, phi triple dash of a is equal to 0. What it will going to help you? I'll check it. Okay, what you have done, you taken simply phi of x function in auxiliary function, which is x is a variable in case of a and b. Then we can, if you work out the, if you choose such a lambda that is equal to phi of b is equal to 0, then apply the rules theorem. You can apply, and it means you have to choose lambda is equal to like this. If you equal to f of b is equal to 0, then what happens, this lambda can be taken like this. Okay, in such a way that we can take and apply the rules theorem. After applying the rules theorem, there exists a c1 such that f dash of c1 is equal to 0. Now again, whatever auxiliary function is there, no, that phi of x, if you work out phi dash of x, and that phi dash of x is also whatever the first derivative, and I can say that phi dash of x is also continuous in a closed interval a comma b. Okay, if you work out difference phi dash of x, and if you work out phi dash of x is also continuous in a closed interval a b and differentiable in open interval of a b, and whatever they given that phi dash of n is equal to 0 and phi dash of c1 is equal to 0, what we can say that we can apply the Rolle's theorem again on closed interval a comma c1 here. See here, you take an interval of not a comma b, I am going to take a comma c1. In that case, whatever this phi dash of x is continuous in a closed interval a comma c1 and differentiable in open interval a comma c1, you can exist, and phi dash of a is equal to 0 and phi dash of c1 is equal to 0, you can get phi double dash of c2 is equal to 0 here. Similarly, if you work out again, we know that phi dash of a is equal to 0. This is by simply you can get, no problem. There's no If you work out, differentiate this one again second time and applying a, if x is equal to a, you can get easily. But this condition you can get by calculation, and again we will the previous one, phi dash of c2 is equal to 0. Whatever c2 is there which is lies between a and b, that is again if you take that, phi double dash of x is continuous in function closed function a comma c2, and there exists and open differentiable in open interval a comma c2, then there exists, I can say that phi dash of c3 is equal to 0. Like that we can prove that phi dash of c4 is equal to 0. Now with these things we can work out phi dash of means fourth derivative of c is equal to 0, and if you work out the fourth order derivative of x is, you can get a fourth order this equation. If you work out this one fourth order derivative, what we can get, you can get fourth order derivative of is equal to 4 in 4 factorial into lambda, and we can after any calculation, what we can get, whatever the lambda if you substitute and we can solve it rearranging this one, you can get like this is how we can get it. Means what, we can whatever the lambda value we substitute here for c4, you can get directly the whatever the result you can get it. This is how we can prove it. But this same function, whatever this same function is there, no, that can be expressed, I can say that same thing, whatever then this, if n is equal to 4, it means the same function, if you take n is equal to 4, the f is continuous in fourth order derivative or continuous and fifth order derivative on open interval a comma b, because since nth order may be anything, you can put n is equal to 4. What happens, this is going to become like this, and we have to prove this one. How can we prove it? But again, by based on the auxiliary function, we have to take slightly different auxiliary function. Like this, we can take it. Auxiliary function f of x is equal to f of x minus like this quantity expression minus of lambda into x minus, I can say that a raised to 5, we can take it. Okay, instead of then, and what we can say that by taking that, again same thing here, phi of a and phi dash of a, they are equal, they are going to become 0. But how can we prove, in order to take in we have to choose lambda in such a way that phi of b is equal to 0, like that. If you choose lambda, you can get lambda like this, and after this phi of a is equal to phi of b, you can get it, and phi of x is continuous and enclosed into a comma bj. Applying the Rolle's theorem, you can get phi dash of c1 is equal to 0. Again we know that phi dash of a is equal to 0 and phi dash of c1 is equal to 0, and phi dash of x is a continuous in a closed interval a comma c1 and differentiable in open interval a comma c2. There exists a c2 such that phi dash of c2 is equal to 0. Similarly, we can we can go on like this, and we can say that fifth order derivative sum c is equal to 0, because again you take previous one, whatever this phi dash of a is equal to 0 and phi dash of c2 is equal to 0, phi double dash of x is equal to continuous in a closed interval a comma c2 and differentiable in open interval a comma c2, there exists like this, you can go on prove it. By that we can fifth order derivative of c is equal to 0. After that, what happens, if you in order to that, you have to compute fifth order derivative of x. If you work out that one, you can get like this: fifth order derivative of x minus 5 into lambda, 5 into sorry, lambda into 5 factorial. Then if you substitute back into the equation lambda value, and once if you solve it, we can get the same thing. What we conclude that whatever f of b is equal to, you can write p3 or P3 plus R3 or P4 plus R4. Like that we can stop at any term. You can say like simply f of b is equal to f of a plus f dash of, you can directly stop here also. If f of b is equal to f of a plus f dash of c into b minus a, that is what the mean value theorem tells. You can stop here only. Second, the already this is same thing again, mean value theorem. You can stop, there exists some c here such that f of b is equal to f of a plus f dash of c into b minus a, you can see that. Or we can stop it here also. We can in continue, and f of b is equal to f of a plus f dash of a into b minus a plus f double dash of c divided by 2 factorial into b minus a uh, whole square. Like that you can put stop here. That is becomes p2 plus, I can say that, sorry, this one is what we can say, mm, p1 plus r1 we can get it. Okay, like that you can uh, stop it anywhere. This is how very important concept, why f of b is sometimes p2 r2 or p3 r3, like that. This is how very important. Okay, thank you.